Hi, in today's session we are going to discuss the conversion of decimal to binaries. So we have this decimal system. We know we have been reading it since kindergarten. This has 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Then we have this binary system which has only 0 and 1 as digit. The reason we are studying binary because it is used by computers, and the system language that computer understands is based on the binary system, and it is used in computer because 0 here represents off and 1 represents on. So first thing, in case of conversion, we need to know that 0 and 1 of decimal are same as 0 and 1 of binary, and the way we write it is, so we have decimal numbers here, we have binary numbers here. 0 of decimal is 0 of binary. This 10 dictates that it is a base 10 number. This 10 dictates it's a base 2 number. Same goes for 1 of decimal is same as 1 of binary. Now coming to other digits which are starting from 2. So we need to know at least how to divide by 2. We have 2. We know here we are going to write quotients of, in this we start by creating a 2-column table in which the second column is for quotient, the first column is for writing 2, and then we have a remainder column here which is far from this table. So when we divide 2 by 2, we get quotient as 1, remainder as 0. So 0 goes here, and 1 can be further divided by, and we know that 1 represents 1 in binary, so we'll just write it like this. So, and the way we read it is from bottom to top. So we have 1 0 of binary, 2 of decimal equal to 1 0 of binary. Now let's go to the next digit. We have 3 as the next digit. So how do we divide it? Again quotient here, that is 1. Remainder here. Remainder is what? 1. Then 1 can't be further divided, so we write it just like this. Here we got 1 1, and so we can write 3 of decimal equal to 1 1 of binary. Now we'll go for 4. So in case of 4, we have 2 as the quotient, so we get the quotient again here. Then we'll write 0 as remainder here because 4 is an even number, so remainder will be 0. Then again we need to, because it's greater than 1, so we can further divide it. We have to divide until we get the 1. So 2, we divide 2 by 2, we get 1 and remainder as 0. So quotient here is 1, remainder is 0, and then again 1 cannot further divided by 2, so we just write 1 here, and we got this 1 0 0. So we can write 4 of decimal equal to 1 0 0 of binary. Now we can continue the same thing for any other number. Let's say we will continue it for some big number, 34. So 34 here, remainder column here, 2 here. This is an even number, we know, and we know the quotient is 17 and remainder is 0. Then again we'll come here, we know it's an odd number, so remainder will be 1 and quotient is 8. 2 8 is 16, so here we get, and then we again come, we have already written remainder, so we'll again further divide it. 2 8, we get the quotient as 4, remainder as 0. Then further division, we get 2 as quotient, remainder as 0. Then further division, we get 1 and here 0. Then 1 here. So what do we have got? 1 0 0 1 0. And remember, we need to read it from bottom to top. So that's how we read it. So 34 of decimal equals to 1 0 0 1 0 of binary. That's it. Thanks.